So note down. So acceleration of wedge, you can write down topic, wedge and block. Triangular wedge. Triangular wedge and block. Ah, yes, yes, come. Triangular wedge and block. This is again important topic. Okay. Like for example, this triangular wedge is like this, and you keep the block here. Okay. And the surfaces are smooth. All surfaces are smooth. So here also it is a smooth surface. A smooth surface. Okay. Actually, this topic is a little bit high level. Okay. But still we have to do it. Okay. It will make your concepts more clear. First of all, this is not friction. Friction is over. Okay. We have finished friction. Some topics are there I will teach, but this is not friction. This is smooth surface. Everywhere it is a smooth surface. Okay. This is not friction. So this is smooth surface, and the shape of this wedge is triangular. So one side it is one face it is vertical, other face inclined. Inclined. So what is the angle of inclination? Theta. Now if you hold the wedge, suppose if you hold the wedge like this, if you hold if you hold the wedge like this, then what is the acceleration of this object down the plane? What is the acceleration? G sin theta. Correct. Good. But suppose if this is at rest, so it will slide down with g sin theta. Correct. Good. And normal will be mg cos theta. Normal will be mg cos theta. Correct. But I want to keep it at rest. How to keep it at rest? That is a question. How to keep block at rest with respect to wedge. Okay, this triangular wedge with respect to this triangular wedge. Triangular wedge is like this. This is a triangle. Actually, I can use this chair also. This is inclined surface. So how I can use it? If you move it like this with very fast speed, like this, and you keep it here, okay, then it will not slide. Then it will not slide. Okay. So you have to exert force from here. So this is the force. So this is the external force. This is the external force. You are exerting force on what? Wedge. This is wedge and this is block. You are exerting force on wedge. You are pushing it like this. So the wedge will accelerate right side. Wedge will accelerate right side. So and block is attached with the wedge. It is connected with the wedge or kept on the wedge. Correct? Block. So block will experience pseudo force. In which direction it will experience pseudo force? Left side. Okay. So acceleration of wedge is A, right side. Okay. So how to keep block at rest with respect to wedge? Accelerate wedge rightward by pushing it from behind, by pushing it from behind. You are pushing it from this, okay? So this wedge will accelerate right side. So what is the acceleration of wedge? A. Now we will calculate A. See how to calculate A. So free body diagram you have to draw. So suppose the observer, this is the observer, observer is this is the observer. So observer is sitting on the wedge, observer is sitting on the wedge. So what type of observer is this? Accelerated or rest? Accelerated, because whole wedge is accelerated. So this observer is also accelerated. So according to this observer, pseudo force will act on this, okay, in left direction. So free body diagram will be like this. This is the MA, pseudo force. Mass of the block is M. This is the pseudo force. This is the surface. So this is the mg, and this is the normal. Correct. So this is the free body diagram. mg downward, ma leftward, normal perpendicular to surface. Normal is perpendicular to surface. So what is this angle? Say theta. This angle is theta. So this angle will be 90 minus theta. Now what is this angle? Theta. This angle is theta. So what is this angle? 90 minus theta. This is 90 minus theta. So what is this angle? Theta. Are you getting or not? So now you take components along the surface. This is the surface. So take components along the surface and perpendicular to surface. So do it. So what are the components? What is the component of MA along the surface? Along the surface. MA, cos or sin? Cos. Very good. And perpendicular to surface? MA sin theta. Okay. Now mg also. What is the component parallel to surface? Along the surface? Mg sin theta. And perpendicular to surface? Mg cos theta. Okay. And this is normal. This is normal. Okay, clear? Note down. So this is the diagram. Observe the free body diagram. Okay. So block is kept on the inclined surface, and you are pushing the wedge right side. So wedge is accelerating right side. So this block will not slip. This block will not slip because it is experiencing force left side. Now what do you want? How to keep block at rest with respect to wedge. So note down. So now balance it. You can use Lami's theorem also. Lami's theorem, or you can use components. So I am using components. Okay, that is better. So components use. So equate these two, you will get A. Equate these. So block is not sliding down. Block is not sliding down. So block does not slide. Block does not slide. So these two are equal. So MA cos theta is equal to mg sin theta. Okay, clear? These two equal. So what is a? Cancel. What is a? G sin theta by cos theta means G tan theta. Note down. So A is equal to G tan theta. Note down. So this is the formula. So what should be acceleration of wedge? G sin theta. G tan theta. G tan theta. Note down. Very important it is. It may come next year, okay, because all concepts we have to understand. Okay, fine. Maybe they will give numerical, they can give numerical, they will give this theta value, and so g tan theta, okay, remember g tan theta, acceleration is g tan theta. Okay. Now calculate normal force. Next, calculate normal. What is the value of normal force? This plus this. Normal force is equal to ma sin theta plus mg cos theta. A value you put, a value is g sin theta by cos theta, put here. So mg sin theta by cos theta, this is a. Now sin theta is also there, plus mg cos theta. Okay, now this is sin square theta, and if you solve this, it will become cos square theta here. So this is mg sin square theta plus mg cos square theta whole divided by cos theta, correct? Like this, a by b plus b, like this. So this is a plus b square by b, correct? So mg common, so mg common, sin square theta plus cos square theta, understood? By cos theta. What is sin square theta plus cos theta? 1. So this is mg into 1 by cos theta. So mg by cos theta, note down, mg by cos theta or sec theta, you can call it sec theta also. Normal force, note down, normal force. So this is the force exerted. What is normal force here? Force exerted by wedge on block. Force exerted by wedge on block. Force exerted by wedge on block. Okay, clear? So done. So I'm finishing here, and I'm giving you one homework. So what is the normal value? Mg by cos theta. Okay, mg by cos theta. I'm giving you homework. You have to find capital F. What is this capital F? I'm not doing in class. You try. Okay. So find the value of F. So F you are exerting like this, correct? So you are exerting force like this. You are pushing this wedge like this. So wedge is moving like this, and block is kept on the wedge, but block is not sliding. Okay, block is not sliding. So acceleration we have found g tan theta, normal we have found mg by cos theta, mg by cos theta. Okay, finish. Okay, finish. Homework is find F. Try this. Okay, we'll discuss some other time. Now next topic you write. Now one friction topic is there, that is insect, not down, insect in a spherical bowl, insect in spherical bowl. Hemispherical bowl, hemispherical. This is hemispherical bowl. So this is the center, this is the center. So radius of the bowl is r, It is a bowl. Okay, it is a rough surface, rough inner surface, rough inner surface. Inside surface is rough. Now suppose you see some bowl is there, container is there, correct? Rice ball, you eat in this rice ball. Okay, so suppose some insect is there, a small insect is there. Suppose this is the insect. Okay, this is the insect. So now insect want to come out. Insect want to come out. So it will walk slowly. We call it crawl. Okay, insect will crawl slowly. Slowly it will crawl because it want to come out of the bowl. After some time it will slip again. So why? Why it will slip? Because as it is crawling, when insect reach here, this point, so if you join, normal will act here. This is the normal. This is the normal. Mg is acting where? Downward. And suppose this angle is theta. This angle is theta. So what is theta when insect is lowest point? What is theta when insect is here? 0. Very good. When insect is here, what is the angle? 90. Correct? But insect cannot reach here. Before that it will slip. Okay. Up to some point it will crawl. Up to some point it will crawl. But after that it will slip again. It will come back. Why? Because theta is increasing. Theta is increasing. So what is the angle of inclination for this insect? You draw tangent here. If you draw tangent here, what is this angle? Can you tell me what is this angle? Suppose this angle is alpha. Okay, this is theta. Now what is this angle? 90 minus theta. So what is this angle? Theta. It is a tangent. Okay, this is tangent. Okay, this is theta. So what is this angle? Same? Correct. So that is also theta. So this angle is theta. This angle is theta. So basically the insect is going along inclined plane for a moment. And what is the angle of inclination? Theta. So it is a rough surface. So it will slip, insect slip, insect slip if tan theta is greater than mu s. Tan theta is greater than mu s. You remember angle of repose? Theta is greater than angle of repose. Okay. And what is angle of repose? Tan theta r angle of repose is equal to mu s. Tan theta r is greater than, equal to mu s. So tan theta is greater than mu s because theta is greater than angle of repose. See, theta is greater than theta r, so it will slip. That means tan theta is greater than tan theta r, or you can say tan theta is greater than mu s. Tan theta is greater than mu s. Okay, note down. Tan theta is greater than mu s. So angle is increasing. Angle is increasing. Okay, 0 degree, 5 degree, 10 degree, 20 degree, 30 degree, 45 degree, 50 degree, 60 degree. Okay, 80, 90. So angle is increasing. As angle is increasing, tan theta increasing. When tan theta is less, insect will not slip. Insect will not slip if tan theta is less than or equal to mu s. Tan theta not slip if tan theta less than or equal to mu s. Tan theta more than mu s means insect slip. Insect slip. Suppose I am saying mu s value is 1. So can you tell me up to what angle it will not slip? 45 degree. Very good. So if mu s is 1, so up to 45 degree insect will not slip. Similarly, if I am saying mu s is equal to say 1 by root 3, so that means up to 30 degree insect will not slip. Okay, insect will not slip. So that is angle of repose, or repose angle. Okay, clear? Now calculate height. So you can assume this is ground level. So I am drawing another diagram to calculate height. You can draw another diagram. This is the center. It is hemisphere. Okay, it is hemisphere. Like sphere, you know, like football. Football, you know, if you cut, this is the football. If you cut it midway, you will get two hemisphere. Correct? Like watermelon you eat watermelon like this. Okay, the two hemisphere. So it is a bowl. So suppose insect is up to here, maximum it is up to here. After that it will try, it will slip. So calculate what height it can reach. So this is the ground level. This is ground level. So up to what height it is going? Up to what height it is going? H. So this is R. This is radius. This is also radius. This is also radius. So how much is this? R minus H. R minus H. And this angle is theta. So what is cos theta? Tell me. What is cos theta? R minus H by R. Good. R minus H by R. And how much is tan theta? You can say mu s. Tan theta is mu s. Angle of repose. Okay. So up to theta, insect can crawl. Insect can crawl up to theta only. More than theta, it will slip. Understood? Okay. Now tan theta is mu s. How to calculate cos theta? If tan theta is mu s, how to calculate cos theta? So look here. Suppose this is theta. Now this is a triangle, right angle triangle. So if tan theta is mu s, so can I say opposite is mu s and adjacent is 1? Can I say like this? Correct. So what is hypotenuse? Calculate hypotenuse. Square root of 1 plus mu square. So what is cos theta? What is cos theta now? Tell me. 1 by square root. 1 by square root of 1 plus mu square. Okay, clear? Now calculate further from here. So r by r, 1 minus h by r is equal to 1 by square root 1 plus mu square. Okay. Now take this left side. So 1 minus 1 by square root 1 plus mu square is equal to h by r. So what is h? What is h? R bracket 1 minus 1 by square root 1 plus mu square. Okay, this is the formula. Note down. This is the h. Okay. So It is practical situation, right? Whatever physics we are studying, it is practical only. You imagine, suppose there is a ball, one insect is there, it is trapped. Somehow it fell from ceiling, it fell on the bowl. Now insect want to come out. Okay. So it will crawl slowly, slowly it will crawl. Correct or not? If the plate is there, flat plate is there, plate, then insect can easily come out. Correct? Insect can, suppose this is the insect, it can simply crawl because it is flat, horizontal. It is flat. It can walk and it can jump. Correct? But here it is not flat, it is spherical. So up to some height it can go. After that it cannot go. It will slip back. It will come back. Okay? Why? Why it will come back? Because of this reason. Because theta is increasing. Theta increasing. So at one time tan theta will be more than mu s. So it will slip. So suppose I don't want insect to slip. So what is the condition? Tan theta must be less than or equal to mu s. So now it is geometry now. So tan theta you substitute mu s. Tan theta is mu s. So opposite is mu s. Adjacent is 1. Correct? Like suppose root 3. Tan theta is root 3. So root 3 by 1. Root 3 by 1. Okay? Like this. Now calculate hypotenuse. Pythagoras theorem. Square root 1 plus mu square. Okay? Clear? So cos theta is equal to adjacent by hypotenuse. So adjacent is what? 1, hypotenuse 1 plus mu square, square root. And according to this diagram, this is R, this is height, this is ground level. So height, now you have to calculate height. So what is cos theta using this triangle? Using this triangle, R minus h by R, R minus h by R. So that is 1 minus h by r is equal to 1 by square root of 1 by 1 plus mu square. Okay, clear? So just rearrange it. Okay. So this is the formula. Okay, done? Clear? Okay. Just remember it. Keep revising. Okay. Keep revising. Keep revising. Okay, done. So insect over. Now next topic you write. Death well. It is friction. This is also friction topic. Previous question also friction. This insect is also friction topic. Okay. Insect in a bowl. Insect in a bowl. Now what is the next topic? Death well. This is also friction. Death well is also friction topic only. Okay. So death well is like this. It is a cylindrical well. Cylindrical. Okay. Now one motorcycle is there. So this motorcycle will come. Have you seen or not this death well? Huh? Everyone? Huh? Okay. So well is there. Sometimes they dig in the ground. Sometimes they construct like this, like a building. Then we don't call it well. It is a building now. Okay. So it is a motorcycle will come. Slowly, slowly it will speed up. Then it will come up to here, and here is students are standing here. They are watching it. Okay. Very high speed they do. Then again they slow down. Okay. They come out. So when it is here performing uniform circular motion, what type of motion? uniform circular motion. It is uniform circular motion. So see, it is performing uniform circular motion like this. So when the motorcycle is here, draw the free body diagram. Okay, draw free body diagram. So here the surface is like this. It is curvature is there, curvature. Okay, like this. So motorcycle is coming like this. Okay, like this. So what is the normal force? Normal force will be left. Normal force is left. Mg is down. Then centrifugal force, not down. Centrifugal force. Centrifugal force will be right side. Friction will be upward. So why? Why it is like this? Because mg is acting downward, so motorcycle should come down. It should fall. But why it is not falling? Because of friction. Friction is acting where? Upward. Centrifugal force acts only when it is in circular motion. In circular motion, horizontal circular motion, horizontal circular motion. Like suppose this object is there, I want to keep it at rest. I want to keep it at rest like this. So why it is not falling now? Because I am holding it. My force is this way. So normal is outward. Friction is where? Friction, tell me friction. Upward. Friction is upward. Mg is downward. Okay. But if I remove my force, it will fall. Okay. So when motorcycle is here, is there someone pushing it like this? No. Because it is in circular motion. Centrifugal force is pushing it here. Centrifugal force. And that is providing what? Normal force. So what is the normal value? Tell me. What is the formula for centrifugal force? mv square by r. So note down. So n is equal to mv square by r. Okay, clear? Now motorcycle will not fall. Motorcycle will not fall. It will not fall if mg is less than or equal to maximum value of static friction, limiting friction. Mg is less than or equal to limiting friction, because friction is 0 to maximum. Okay. So when mg is more, friction is more, but friction has limit f max. So what is the formula for f max? Mu s n, and n is equal to mv square by r. So substitute mg is less than or equal to mu s mv square by r. Mm cancel. So g is less than or equal to mu s v square by r. So you write like this. You write this left side, this right side. Okay, like a is less than b, so b is greater than a, like that. Okay, 2 is less than 3, so 3 is greater than 2. Like this I am doing here. So mu s v square by r is greater than equal to g. So what is v square? Greater than equal to rg by mu. Understood? This is the formula. So v must be greater than or equal to square root rg by mu. Note down. V must be greater than square root of rg by mu. One numerical I am giving. Death well radius. Death well radius is 20 meter. And the coefficient of static friction, static friction is 0.5. Find minimum speed, means I am asking this. So V must be greater than or equal to this, means minimum is this. More than this, it is okay, good, but at least this much, minimum, minimum this much. Find minimum speed to avoid falling, to avoid falling. Find minimum speed of motorcycle to avoid falling. So calculate. So use this formula. Okay. Minimum speed to avoid motorcycle falling. What is answer? 80, 20. Okay. So minimum speed is equal to square root rg by mu. So 20 into 10 by mu. Now mu is 0.5. 0.5 means 1 by 2. Correct. So square root of 400. 20 meter per second. Okay, clear? Done. So this death well is okay. Okay, finish. Just revise, keep revising this. So formula, in formula diary also you write down this formula. Okay. So this friction chapter is over now. So now we will discuss some more questions. So just few more questions, basic questions I am giving. Note down, a student of mass 50 kg start running. Now question I am giving, okay, that death well finish. Death well formula, what is the formula? Square root of rg by mu. Okay, finish. Normal, what is the normal formula? mv square by r. Normal is mv square by r. Okay, clear? Now this chapter is over, laws of motion is finished. Okay, pseudo force we have finished, friction we have finished, spring force also we have finished. Okay, more practice we have to do. Okay, fine. Normal, tension, okay, connected bodies, blocks, pulleys. Okay, we have finished it. Now work for energy we have to start. But before that, I am giving some basic questions. You practice it. Now which one? Momentum conservation. Yes, in work for energy we will do. Okay, work for energy. In before collision and explosion, collision and explosion. What is difference in this collision and explosion? Collision means two bodies coming close. Explosion means going away. Okay. So I will teach this momentum conservation. I will teach in this. Okay. Because it is better to study kinetic energy also before that. Okay. Kinetic energy, half mv square. Correct. So along with work for energy, I will cover this. Okay. So solve this. A student of mass 50 kg start running and on horizontal rough road. On horizontal rough road. On horizontal rough road. It attains speed 20 meter per second. 20 meter per second is very much. 10 meter per, you can note down 10 meter per second. It attains a speed of 10 meter per second in 8 seconds. It attains speed of 10 meter per second in 8 seconds. Find mu, coefficient of static friction, coefficient of static friction between Mu is the property of surfaces, okay, two surfaces in contact. So between shoes or legs, shoes and road, shoes and road, one student is running like this. So yesterday we discussed, suppose you want to run, okay, so you want to run right side, you want to start running right side. How friction is helping you? You want to run right side, friction is acting where? You want to run right side, friction will act where? Right or left? Right. Friction is helping, are you getting or not? Suppose I want to run, friction is helping me, are you getting or not? That hills and valleys, hills and valleys. So this is your shoes surface, okay. When you, actually shoes are like this is the shoes, but if you see from microscope, the surface of shoes is like this, correct? And ground is also like this, ground is also like this. So these are known as hills and valleys, hills and valleys, okay. So friction is acting right side, okay. So what type of friction? Static or kinetic? Static. It is not slipping, without slipping. Like this it is walking, like this, okay, without slipping. This is slipping. This is not slipping. Are you getting or not? So good grip. If grip is good, so it will not slip. So what type of friction? Static. The shoes are not slipping. You are just putting the shoes like this and removing, putting, removing like this. So what is the minimum coefficient of friction needed? What is the minimum coefficient of friction needed? So you can use maximum friction formula. What is the maximum friction formula? Mu s n. And what is n here? Mg. Now equate it with ma. So what is the acceleration? What is the acceleration? Mu g. Now use v is equal to u plus at. Use it. V is equal to u plus at. So okay, u plus at. So what speed you are acquiring? 10. What is the initial speed? Initial speed 0. And what is the acceleration? Mu g. And time, what is the time? 8. Now calculate. So 10 is equal to 8 mu g. Okay, g is 10. So 10 is equal to 8 mu into 10. 10 cancel. So 8 mu is equal to 1. So mu is equal to 1 by 8. Okay, clear? Note down. Mu is equal to 1 by 8. So this is also basic question of friction. Okay, but you have to understand it. This is the concept. For a time being, you just memorize it. Okay, slowly you will understand. Don't worry. Keep revising, you will understand. It is a static friction. When I am walking like this, what type of friction is acting? Static friction. Okay. When you walk, it is a static friction. If slip is not there, without slip, okay, without slip, if slip is there, it is kinetic friction. Like car also, suppose these are the tires of the car. So engine is there, this is the engine. Engine is connected to front wheel. So what engine will do? It will rotate it. How car moves forward? What engine will do? Engine will rotate it, rotate. Engine will rotate it. Suppose car want to go right side. How engine will rotate the tire? Clockwise or anti-clockwise? Clockwise. So these are the 2 points. These are the 2 points, A and B. Now A is the lowest point of the tire. Okay. Suppose this is the tire. So this point is A. So where A is going? Suppose it is going it is rotating clockwise. Where A is going, right side or left side? Left side. So motion of A is left side. So A is going left side with respect to B. So what is the friction on A? Direction of friction on A? Right side. Very good. So B is the ground. B means ground. And A means tire. So lowest point of the tire. Lowest point tries to go left. So friction will be right side. So this friction is static. Okay, this is static friction because there is not slip. There is no slip. No slip. So this friction is acting where? Forward. Are you getting? So because of this friction, who is exerting this friction? Who is exerting this friction? Ground. Okay, ground. If ground is slippery, car cannot go forward. You know, if ground is slippery, what happens? Suppose this point is A, this point is B. Now ground is smooth. Ground is smooth. Okay. So the engine, this is the engine. It is connected to the wheel. Engine will rotate it. So where A will move, right or left? A. It is rotating clockwise. Where A will move? A will move left side. Correct or not? But it is a smooth surface. So B will exert any friction? No friction. Are you getting? So B will exert no friction. So wheel will rotate only. We will rotate only. It will not go forward. It will just rotate. But car will not go. It happens in the monsoon season. Monsoon season, you know. So uh, more rain is there. So potholes are there. You know, potholes. Suppose some hole is there, water is there. If your car get struck, car get struck. If your car get struck, the wheels will rotate. Are you getting or not? So wheels will rotate, but car will not go forward. Okay, why? Because the ground becomes smooth. Okay, so we need rough surface. If rough surface is there, so friction will be there. Okay, see, the lowest point want to go left, so friction will be right. Okay, so this friction is taking the whole car, you know, forward. Okay, understood? I will discuss this more on rotational motion. Okay, this is rotational motion. I will discuss more on this. So answer you got that running person, you got running person answer. Okay, 1 by 8 mu is equal to 1 by 8. Now I will ask opposite question. Suppose running person want to come to rest. Running person want to come to rest. Note down. A student running with speed, a student running with speed 20 meter per second on horizontal rough surface. Horizontal rough surface. If mu s is equal to 0.6, after what distance student come to rest. Come to rest as it slow down. As it slow down. Speed decreasing. Okay. Like student running, speed decreasing. Okay. Like this running, speed decreasing. Final velocity, tell me. 0. And initial velocity 20. Now friction is helping again. Friction help in both the cases. Friction help to accelerate and friction help to decelerate. Here acceleration or deceleration? Deceleration. This is deceleration. Okay. We need a rough surface to accelerate and to decelerate. So now this is the person. So it is going in right direction but slowing down. It is slowing down. Okay. It is speed is decreasing. So what is the direction of friction? Left side, static friction. Okay. Static friction. So friction is left side. So mu mg. Friction is mu mg. Okay. Normal is mg. Okay. Fine. Normal is mg. And friction is left side. So because of this friction, it is slowing down. Motion is right side, but force is left side. Retardation. So this is retardation. Now calculate distance covered. What distance it will cover? So distance cover is s. Acceleration will be plus or minus. Acceleration will be plus or minus. Minus mu g. Okay, mu mg is equal to mu a. Sorry, ma. Mu mg is equal to ma. So mm cancel. So a is equal to mu g. Direction is left. So take minus mu g. Now which equation you will use? Kinematics. V square minus u square 2as. Good. Zero square minus 20 square is 2 into minus mu g into s. Calculate mu value I have given. G is 10. Now minus minus cancel. 400 is equal to 2 into 0.6 into 10 into s. Okay. So 400 is equal to 2 into 6 into s. Okay. 0.6 into 10, 6. So 400 by 2 means 200. 200 is 6s. 200 by 6 is equal to s. 100 by 3 means 33.33 meter. 33.33 meter. Okay, clear? So these are all basic physics. 100% chance is there this type of question can come. Are you getting or not? Okay, neat paper. So Olympic, if you see Olympic that runners are the racer, what you call athlete, they run very fast. They that whistle is there, so they all start running. Who is helping to run? Friction, correct? So when it started running, what is the direction of friction? Oh, sorry, forward. When running is started, what is the direction of friction? Forward. Now running. Now that what you end is coming, and finish line coming. So they want to stop now. So friction, where it will act? Friction backward, correct? Backward. Okay, clear? Okay, because they have to stop. Okay, fine. So this this is, you tell me, this is kinetic friction or static friction? I'm I am exerting force. Chair is not moving. What type of friction acting here? Tell me. Static. Correct. Good. But suppose I give some speed, it stops. Okay. It stops here. So what type of friction acting? Kinetic. So solve one question on this. Block is given speed of 10 meter per second on rough surface, rough horizontal surface. Okay, like this. This is the block. What speed I have given? 10 meter per second. But finally it is stopped, correct? So it stops. It stops after 2 meter distance. Now calculate mu. Calculate mu. Now it is kinetic friction because it is a block. Okay. So mu k. So you have to calculate mu k. It is kinetic friction. Sliding means kinetic friction. Running, when you are running, it is static friction. Running means static friction. So how will you solve this? Same formula you will use. Mu v square minus u square is equal to 2s. What is final speed? Final speed 0. Initial is 10. Now it is retardation or acceleration? Retardation. It stops after 2 meter. So 2 into minus mu kg. Okay, this is the retardation value because block, this is the block, left side friction is there. Friction is mu k n is equal to mg. So mu k mg. So mu k mg is equal to ma. Mu k mg is equal to ma. Mm cancel. So mu k is mu k into g is equal to a. Mu k into g is a, left side. Understood? Left. So minus 100 is equal to minus 2 into mu k into g. Minus minus cancel. 50 is equal to 10 into mu k. 10 10 cancel. So answer is 5. Note down. Mu k is equal to 5. Tell me this one. See, it is like this. Suppose this is the block. I have given a speed like this. So I have given a speed. Final speed, tell me what is final velocity? Final velocity 0. And what is the initial speed I have given? 10 meter per second. So it is deceleration. This is deceleration. Why it is stopped? Why it is stopped? Because of kinetic friction. Understood? This is kinetic friction. Remember, kinetic friction means sliding is must. For kinetic friction, sliding is must. For sliding friction, for kinetic friction, sliding is must. You note down this point. Sliding is compulsory. For kinetic friction, sliding is must. Okay, so this is sliding. This is sliding. One more example I will give in which you see sliding. I have observed this in small classes, class 1, class 2. If you go to any school, Nowadays, in break time, suppose classroom is very big classroom. So suppose this kid is there, it is running, it is running and slipping, running and slipping, and finally stop like this. So what type of friction is acting? Static or kinetic? When it is running and now it want to stop, wall is there. Suppose here wall is there, student is running, wall is there. Now it has to stop, otherwise it will hit the wall, correct? And head injury, correct? So now this kid knows it. Kid knows it. Wall is there. I have to stop. So instead of running, it is slipping like this. Are you getting? It is slipping like this. So it is slipping. So what type of friction is there? Kinetic friction is there. Kinetic friction is there. Okay. Okay. Now, yeah, G effective. One more topic I want is G effective. You can note down. Suppose this is the elevator. It is not friction. This topic is not friction. It is apparent weight. When elevator is there, it is at rest. Then what is the actual weight? Mg. So normal is mg. Correct. Normal is mg. It is at rest or uniform motion. Rest or uniform motion means velocity constant. So actual weight. Normal is actual weight. But suppose the same elevator is accelerating upward. Elevator is accelerating upward. Now what is a normal force? Mg plus ma. Very good. So actual weight is actual weight is mg, and pseudo force is ma. Pseudo force will be ma. So n is equal to mg plus ma. You take m common, so it is g plus a. So this is known as g effective. This is known as g effective. Effective g. Okay, g effective. Note down. G effective. And if elevator is accelerating down, acceleration is downward. So normal is upward, ma is upward, mg is downward. Correct? So normal plus ma is equal to mg. So what is normal? Mg minus ma. So what is normal? M common, g minus a. So this is g effective. So m into g effective. Okay, note down. So what is g effective when it is at rest? G. Correct. Acceleration is 0. So g effective is g. Correct. When acceleration is upward, what is g effective? G plus a. When acceleration is upward, g effective is g plus a. When acceleration is downward, then what is g effective? G minus a. Okay, remember this. Acceleration upward, g effective is g plus a. Acceleration downward, g effective is g minus a. Okay, clear? Just remember this. Then in a formula diary also you write down. Now one question is there in your DPP. there is an elevator, there is a spring balance here, and one pulley is there, and two blocks are connected. Now what is the mass of this block? 1.5 kg, and this is 4.5, 3 kg. This is 3 kg. And elevator, this is the elevator. Elevator is accelerating up or down? Up, up. What is the acceleration? G, G by 2. G by 10. G by 10. Elevator is there, it is accelerating upward. So you can take G effective, acceleration is upward, acceleration is upward. So what is G effective? G plus A. So G plus G by 10. So 11G by 10. Okay, this is the G effective. Okay, note down. Now you solve as a normal question. If it is a normal question, how you solve it? Like suppose pulley is there, left side M1 is there, right side M2 is there. So how do you calculate tension? What is the formula for tension? Direct formula. What is the tension? Tension 2 M1 M2 G by M1 plus M2. Correct? This is the formula for tension. And here also tension. So what is the force by the clamp? 2T. Force by the clamp is 2T. Now say apply the same formula here also, but don't take G here, take G effective. So what is the tension now? Calculate. Tension, okay. So this is tension. So here it will be 2T. So read, this is the spring balance. Okay, this is the spring balance. So spring balance reads tension. So here what is the tension in this string? 2T. Spring balance reads 2T in this question. If you have a spring balance like this, suppose this is the spring balance and one block is there. Now what is the reading of this spring balance? What is the tension here? Mg. So this will read Mg, correct? It is a ceiling. This is the ceiling. So this spring balance will read what? Mg. Mg Newton or M kg. Now come here. So this spring will read tension in this string. So what is the tension here? 2T. And T calculate. How to calculate T? Use this formula. So 2 M1 M2 into G effective. And first you tell what is G effective. How much G is G effective? Tell me. 11G by 10. 1.5 plus 3. Okay, so this is 2 into 1.5 into 3, 4.5, and G effective 11G by 10 whole divided by 1.5 plus 3, 4.5. Okay, 4.5, 4.5 cancel. And G value is 10. So 10 by 10 cancel. So 2 into 11. So what is the value of T? 22. So what is the spring balance reading? Spring balance reading, tell me. T is 22. So what is the spring balance reading? 44. So 44 Newton. 44 Newton means 4.4 kg. Okay. So reading is 4.4 kg. Okay, clear? So note down. Note down. Okay, clear? One more question is there. Give me DPP. DPP. Yesterday. Before yesterday. This is what? Before this yesterday. One question is there. So these all questions you are doing, right? Any question in this? Tell me. Any doubt? Hmm. So this yesterday test, yes. Yesterday, day before yesterday. This is date. The date is also written, na? 27. One question is there. You come to that question. So question 26. Question 26. 27 August. This question. So two blocks are there. This is the inclined plane. It is rough or smooth? Rough. Figure shows two blocks in contact. This is also important question. 4 kg, 2 kg. Angle of inclination 30. The friction coefficient between block 2 kg and incline is 0.2. It is 0.2. Between this mu is equal to 0.2. Mu1 is equal to 0.4 kg and inclined plane, what is the coefficient of static friction? 0.3. Mu2 is equal to 0.3. What is the acceleration of 2 kg block? First you see 4 kg will slide or not. For 4 kg, what is tan theta? Tan theta, what is tan theta right now? 1 by root 3. What is 1 by root 3? 0.577. And what is the mu2 value? What is the mu2 value? 0.3. So tan theta is greater or less than mu? Greater. So block 4 kg will slide or not? Slide. Tan theta is greater than mu2. So 4 kg block, it will slide. Okay, you can call it block A, block B. So block A slide. Block A slide. Now same find for 2 kg. What is tan theta value? 1 by tan 30. Tan 30 is 1 by root 3 means 0.577. And what is the mu value? 0.2. So it will slide or not? Slide. tan theta is greater than mu, so it will slide. Suppose individually they are sliding. Suppose this is 4 kg and this is 2 kg. Find the acceleration. Find the acceleration separately. What is the acceleration of 4 kg? G sin theta minus mu g cos theta. So calculate this for 4 kg. A2, acceleration A2. Sin 30 minus 0.3 into cos 30. What is cos 30? Root 3 by 2. Calculate this. G by 2 common. 1 minus 0.3 into, take root 3 as 1.7. So G by 2, 1 minus, now calculate this, 0.3 into 1.7. 51. 0.51. 0.51. So this is G by 2. Now 1 minus 0.1 is 0.49. So 0.49 into 10, 4.9. 4.9 by 2. So 2.45. Okay, 2.45. So acceleration of 4 kg is 2.45. Now calculate acceleration of 2 kg. Only mu value will change. So A1 for 2 kg. For 2 kg, A1 will be G sin theta minus mu1 G cos theta. Okay. So G into 1 by 2 minus now mu1 is 0.2 into cos 30. So G by 2 common, 1 minus 0.2 into 1.7. Now 0.2 into 1.7, 0.34. So G by 2. So G by 2 into 0.66. So 6.6 by 2, 6.6 by 2. So 3.3. 3.3. So which has more acceleration? 2 kg or 4 kg? Which has more acceleration? 2 kg more acceleration, correct? So 2 kg acceleration is more. So 2 kg is more acceleration, 4 kg less acceleration. So 2 kg will push 4 kg. 2 kg will push 4 kg. So both will come together. Okay, both will come together. If both are coming together, so the downward force will be combined mass 6g sin 30, and one friction will act here, one friction will act here. So for this friction will be 0.3 into mg cos 30. Okay, and this friction on this 0.2 into 2g cos 30, correct? Now you find the difference, this minus this minus this, and equate it to ma 6a. Okay, this is common acceleration, so solve this. 6g sine 30 minus, calculate, this is 1.2 and this is 0.4. 1.2 plus 0.4, how much? 1.2 plus 0.4, 1.6. So 1.6 g cos 30, 1.6 g cos 30. Now, so g common, 6 sin 30 minus 1.6 cos 30, correct? So g by 2, 6 minus, now calculate again this, 1.6 into 1.7. 2.72, correct? Check the calculation. Into g by 2, so 10 by 2. Now 6 minus 2.72, how much? 3.28. So 10 into, so this is 32.8, 32.8 by 2. 32.8 by 2. So this is 16.4. 16.4 net force, correct? What is the net force? 16.4. Are you getting? Okay. You just copy this, then in a break time you revise it. Okay. So net force is 6.4. Now equate it to MA. F net is equal to total mass. Now total mass into common acceleration. Total mass into common acceleration. They are going together. Why they are going together? Tell me. Why they are going together? Why? Which has more acceleration? Correct. 2 kg has more acceleration. So 2 kg is pushing 4. Understood? So calculate what is the, now calculate this. So 16.4 is equal to 6a common acceleration. 16.4 by 6. How much? 8.2 by 3. 2.73. Huh? 2.73. So note down 2.73. Okay, okay. Now break time there. You just copy this. I will explain it again. Okay, no problem. You just see. This is lengthy question. I know. NEET it will, chance is very less. It will come on it. But I will now after break we will interchange it. I will put 2 kg here, 4 kg here. Okay. Then you solve the same question, right? Okay, understood. Chalo, let's now take break and we'll continue.